Hello everyone. Today in this beam we are going to derive the expressions for slope and deflection using conjugate beam method. In this beam there is a clockwise concentrated moment m which acts at a distance of a from the left support. This beam we have already analyzed for shear force and bending moment. Also, we have made the expressions for slope and deflection using Macaulay's method. There is a link in the description. You can click the link and watch the video. The left side reaction will be acting downwards and the right side reaction will be acting upwards. Anyway, we are not going to use both of them. This is the bending moment diagram. On the left of the concentrated moment, it will be negative, and on the right side, it will be positive. This is the conjugate beam. Let us keep this loading as downwards and this loading as upwards. I have kept the negative side as downwards and the positive side of the movement as upwards. Let us keep RA dash as upwards and RB dash as downwards. To find RA dash, let us take moment about B dash. In this case, we have to follow right hand side rule. This is acting in the clockwise direction, so positive, and the distance is L. Let us take this UVL. It is acting in the anti-clockwise direction, so it will be negative. For the UVL, we have to multiply the area with the centroid distance. The area formula is half into BH. Here the breadth is A and this is the height. So this is the area. The centroid distance about C dash is 1 upon 3 into breadth. Here the breadth is A. So it is 1 upon 3 into A. But we are taking moment about B dash. So we have to add the remaining distance as well, which is B. Let us take this UVL. It is acting in the clockwise direction, so positive. This is the area, half into B into this height. And the centroid distance about B dash is 2 upon 3 into breadth. Here the breadth is B, so it is 2 upon 3 into B. Here we can take LCM. We have to multiply B with 3, so it will be 3B. A into A, it will be A square. We can eliminate 2, b into b into b, it will be b cube. We can take both of these two terms on the other side, so they will come with a change of signs. We can multiply this term with a square so that we will get this. From these two, we can take m upon 3 LEI outside. We can take this L on the other side, so it will come in the denominator. L into L, it will be L square. For these two terms, we have to take LCM. We have to multiply BQ with 2. 3 into 2, it will be 6. We know that A plus B is equal to L. So A will be L minus B. And A square will be L minus B the whole square. Instead of A square, we can write L minus B the whole square. And A cube will be L minus B the whole cube. So for A cube, we can write as L minus B the whole cube, and we can use this formula. Using this formula, we will get this. Here we can apply A minus B the whole square formula. The formula will be A square minus 2AB plus B square. So it will be L square minus 2BL plus B square. Then we have to multiply this with 3B. So we will get this. 3BQ minus 2BQ minus BQ, we can eliminate 3L square B minus 6LB square plus 3LB square, it will be minus 3LB square. From these two, we can take L outside, then we can eliminate, here it will be L. This is the expression for RA dash. Now let us apply this rule and to find RB dash. It is acting upwards, so it will be positive. This is acting downwards, so negative, and this is acting upwards, so positive. RB dash is acting downwards, so it will be negative. For the UVL, we have to take the area. For the left side triangle, this is the area, and for the right side triangle, this is the area. We can take RB dash on the other side, so it will come as positive. From these three terms, we can take m upon 2 LEI outside. Then we can take LCM. We have to multiply these two with 3. We can eliminate 3B square. 3 into 2, it will be 6. So this is the expression to find RB dash. Using the right hand side rule, we can find the shear force at A dash. It is acting upwards, so positive. Using the left hand side rule, we can find the shear force at B dash. It is acting downwards, so it will be positive. We know that both of them are the slope expressions in the real beam. Let us make a section XX at a distance of x from A dash. We need to find this height. For the distance of A, this is the height. So for A, this is the height. But we need the height at the distance of x. So we have to multiply with the x. Then we can eliminate A. In this way, we will get the height as mx upon LEI. Using the right hand side rule, let us find the bending moment about the section. RA dash is acting in the clockwise direction, so positive, and the distance is x. Let us take the UVL. It is acting in the anti-clockwise direction, so it will be negative. We know the area formula, half into pH. Here the breadth is x and this is the height. So this is the area. The centroid distance about the section is 1 upon 3 into x. From these two terms, we can take m upon 6 LEI outside. Using this expression, we can find the deflection in the real beam from the point A to the point C. That means when x varies from 0 to A, the maximum deflection will occur in the large portion AC. Let us see how to find the maximum deflection. Deflection will be maximum when the slope is 0. From the deflection equation, we can find the slope equation. For that, we have to differentiate the deflection equation with respect to x. For x, it will be 1. For x cube, the differentiation will be 3x square. We can take this term on the other side. It will come inversely. When we multiply that with 0, it will be 0. We can take this term on the other side, so it will come as positive. So this is the expression for x. Now let us find the maximum deflection. In this one, instead of x, we have to apply this one. We can write x cube as x square into x. For x square, this is the expression. We can apply that. And if for x, we can apply this. Here also, we can apply x. From both of these, we can take root 3 outside. We know that power of this is 1. L square minus 3b square power 1 into. Instead of this root, we can write the power as of. So L square minus 3b square, the power 1 upon 2. Here we can use the formula a power m into a power n is equal to a power m plus n. So 1 plus 1 upon 2, it will be 3 upon 2. Then we can take this outside. So inside we will have 1 minus 1 upon 3. So it will be 2 upon 3. We can eliminate 2. Here it will be 3. 3 into 3, it will be 9. This is the expression to find the maximum deflection. To find the deflection under the point movement. In this one, instead of x, we have to apply a. From both of these two, we can take a outside. We know that L is a plus b. So L square will be a plus b the whole square. That will be a square plus 2ab plus b square. We can eliminate a square. B square minus 3b square. It will be minus 2b square. From these two, we can take 2b outside. We can eliminate 2. Here it will be 3. If you want to keep this expression only in terms of a, instead of b, we can apply L minus a. And here it will be a minus L minus a. So it will be a minus L plus a. Finally, we will get 2a minus L. Let us see how to find the deflection in the midspan. Instead of x, we have to apply L upon 2. From these two, we can take L upon 2 outside. 2 into 6, it will be 12. We can eliminate L. These 3 times, we can take LCM. From these 2 times, we can take 3 outside. We can eliminate 3 and here it will be 16. This is the expression to find the central deflection. This is the expression we have made to find the deflection from the point A to the point C. If you wanted to find the deflection from the point B to the point C, this is the expression. Here we have to add a negative sign and instead of B, we have to apply A. This is the expression for the maximum deflection we have made. If A is greater than L upon 2, if A is less than L upon 2, this is the expression. Now we are going to end this session. Thank you for watching this video.